So we're now going to talk about the addition formulas for the sine and cosine. So these formulas may look a bit daunting if you're not used to them, but there is a certain rhythm to them, so they're actually quite easy to remember. So in both cases, if you just want to memorize them, which I kind of recommend you to do, there's not much in calculus you should memorize, but this is one of those things. So what is it? Well, in both cases, you start with the function you're looking at. So here you start with the sine, here you start with the cosine. I'm putting sine here, cosine here. You start with your angle, your first angle in both of them. But for the sine, you flip to the cosine, and then you flip the angle. And for the cosine, you keep the cosine, but you still flip the angle. And for the sine, you put a plus. For the cosine, you put a minus. And then you just put the opposite expression here. So here I flip from sine to cosine. And, well, I keep my angle here. And then here I flip from the cosine to the sine. Keep my angle here. And down here, I do the sine of A, and then I do the sine. So you can also see here that sine A appears once, sine B appears once, cosine B appears once, and cosine A appears once. Same here, same here. And what happens if I put a minus here? Well, then this turns into a minus. What happens if I put a minus here? Then this minus turns into a plus. So how to prove these formulas? Well, I usually remember, I remember a certain proof, but kind of funnily enough, I don't remember what it is that I'm proving. So I kind of have to do this proof before I remember which one of these 4 rules it is that I'm proving. After you've proven this one of these rules, you can then just use translation formulas to get the others, okay? So you just need to prove one from scratch, and then the others follow by doing small tricks to this. So the proof is geometric. So this is not an analytic proof from the axioms only, because we have defined sine and cosine in terms of geometric objects. So that's a deficiency here if you're if you just want to use the axioms for the real numbers. Now I take my angles A and B, and well, let's here have the angle A, here have the angle B, and here I get a point. I will call it, just to keep things simple, PA. We'll call this PB. And then over here, I'll do the angle A minus B. So I'm going to do the proof now for cosine or sine of A minus B. So here I'm putting P A minus B. And here I'm putting P0. So I'm putting here points on the unit circle, and my index here, or my subscript, just denotes the angle. So P theta would denote the point cosine theta, sine theta. So here I have with angle 0, A minus B. So what happens next in this proof? Well, what happens next is that I equate the 2 things here that are equal and interesting. So it's the distance between these 2 guys and the distance here. They are equal because the angle here is the same as the angle here. So what happens now? We just set up an equation equating these 2 distances, and then we simplify, 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 and then we're done. So we need to know the distance between PA and PB. We need to know an expression for this, and we set it equal to the distance between P0 and PA minus B. Now the distance is computed in terms of Pythagoras here, which means it's the square root of something. So we might as well square it to get rid of the square roots. And then we can write out. So what? Well, if I now draw a triangle here, what's the length of this hypotenuse? Well, that's the square root of this guy to the square and this guy to the square. So what's the thing here? Well, who is PA? So PA is cosine A sine A, and PB is cosine B sine B. So the difference here between x coordinates is the difference between these 2 guys. And the difference between the y coordinate is the difference between these two guys. So the distance here squared, according to Pythagoras, is cosine A minus cosine B to the square plus sinus A minus sinus B to the square. And then I can do the same here. So I do a triangle here, right angle here, right angle here. So here I have the point with angle 0, so it's just 1 naught. And here I can just, well, write it out. It's the cosine of A minus B, sine of A minus B. So what's the difference in x coordinates? Well, it's 1 minus this. So here I get 1 minus this to the square. And then what's the difference in the y direction? Well, he has y component 0, and this is the y component there. So I just get sine squared of A minus B. So now I've expressed the distance between these 2 points to the square and the distance between these 2 points to the square. So that's the length of this thing here to the square is equal to the length of that thing there to the square. Now I can simplify. So let me multiply out. So I'll start here to make sure I have enough room. So 1 minus 2 cosine A minus B plus cosine squared A minus B was that guy, sinus squared A minus B. And this is equal to the sum of these two products. So here I get cosine squared A minus 2 cosine A cosine B plus cosine squared B. And then let's add this guy a little bit below here. So that's sinus squared A minus 2 sinus A sinus B plus sinus squared B. So I know that this thing here is equal to that thing here. Now this all seems very, very complicated. Let's try to see what we got here. So let's keep the 1 here, and then, well, let's keep him as well, 2 cosine A minus B. But what happens here? Well, here we have cosine squared plus sine squared, and it's of the same angle. So here we can use the Pythagorean identities to say that this is 1. So I get this 1, I have this 1, so together this is 2. Does the same thing happen here? Well, gee, let's look. This plus this gives me a 1, and this plus this gives me a 1. So I get a 1 plus 1 here as well. And then I get my minus 2 cosine A cosine B, and then minus 2 sinus A sinus B. And of course, this 2 here, I can kill against this 2. So I'm subtracting 2 on both sides. And then I can divide by minus 2 everywhere. So this goes away, and I get a plus here. And this goes away. And what am I left with? Cosine of A minus B is equal to cosine A cosine B plus sine A sine B. That's exactly the second formula inside of here. So cosine A minus B is equal to this plus that. And then, yeah, up to some tricks to get these other guys from this formula, we are done.